Okay, here we are at the top of page 4. We're still in section 2.6, solving inequalities. So now we're deep into the assignment here. 72, 76 are the problem numbers that we're looking at. So there's going to be those extra pieces involved like we got used to earlier in the chapter. Parentheses, variables on both sides of the equation, like terms that we have to combine before we can start undoing what's happening to the variable. So let's work through a couple of these, then I'll turn you loose on some tries in the next video. And they're very, the tries I'll have you do in the next video, I've selected them on purpose. We'll talk about that in the next video, why I selected those. Let's look at number 72 here. We start by noticing it's an inequality. Okay, it's a greater than right now. I've got parentheses in here. That's the first thing I check for. So just focusing on the left side now, I'm going to go ahead and remove the parentheses. And I'll need to do that using distribution. Why do I know it's distribution? Well, I know it's multiplication because there's a number snuggled right up next to it. But is it just multiplication, or do I have to distribute the multiplication across addition or subtraction? And because I see that minus in there, which is really the same as adding a -1, okay, I am distributing this across two pieces here. So there's two multiplications that happen. Okay, in this case, I have to use distribution to remove the parentheses. Okay. So it's going to be 4 times the 2y plus 4 times the -1, and that's going to get me my greater than 12. So I've got my 2y minus 1 greater than 12. So there's my distribution. That gets me 4 times 2y is 8y, plus 4 times a -1 is a -4, or plus a -4, however you want to think about that, greater than 12. Okay. If you have a different way of thinking about positives and negatives and it's working for you, it consistently gets the right answer, you write that in your notes. Make the notes really come alive for you. Make the notes tell the story that will help you understand the problem. Sometimes that means writing more than you see or think, and that's one of the study tips from class. So make the page talk to you so that it makes sense for you. Okay. So we took care of parentheses. There's no like terms to combine on either side of the inequality here. And y has picked a side. It's over here on the left. So we are now at the point where we can ask ourselves what's happening to y. And there's two things. First, it's getting multiplied by 8. The next thing that happens to y is 4 is being subtracted from it. And if we were to do that in kind of a timeline version, we'd have y here. We'd start by multiplying by 8, and then we'd subtract the 4. It's just a way to create a list for yourself, okay? It has nothing to do with order of operations in terms of writing out the timeline. It's just a way to create a list. Now we undo that. This is the doctor's prescription. How do you get yourself solved? How do you solve this problem? We need to reverse our steps and do opposite operations. So step 2 becomes step 1, step 1 becomes step 2, subtraction becomes add, multiply becomes divide. As we go right to left on this timeline, I run into -4 first. I'm going to make that +4. I run into times 8. I'm going to make that divided by 8. We make it the opposite operation. We don't change the sign of the numbers, we just do opposite operations. So we start by adding 4 to both sides. That's what our prescription says to do. Right to left on the timeline, reverse order up the list. That leaves us with 8y. 4's cancel, that was the whole point. Greater than or equal to 12 plus 4 is 16. Our list then tells us to divide both sides by 8, so that's what we're going to do next. Our timeline also, as we go from right to left, we are to divide both sides by 8. That's what this little fraction bar means. Okay, so the fraction bar is the same as dividing by 8. This is just a visual representation of that. Makes it a little bit easier to keep moving down the page with our solution. 8 divided by 8 is 1. 1 times y is just y. Y is greater than 16 divided by 8 is 2. We never multiplied or divided by a negative, so there was no flip here. Okay, there was no flip in this equation. So we've got our solution. We go ahead and we haven't been practicing checking our answer here. Let's talk about that. The number line really comes in handy here. What you can do one of two things. First, you can check where the solution set is, but what's real critical is 2 correct? So it says if you replace this with an equal sign and imagine plugging 2 in, is this the turning point? Okay. Well, it's the turning point if this number that you get, plugged it in, it equals 12, okay? So you can check using an equals. So 2 times 2 is 4. 4 minus 1 is 3. 3 times this outside 4 is 12. That does 12. So we do know that does equal 12. So we do know that 2 is our turning point. 2 is, or maybe a dividing point. Not that we're doing division, but it's the way to separate the true solutions from the non-true, the answers from the non-answers, the ones that work in this inequality versus the ones that don't. 2 is where it cuts the number line, okay? So greater than 2, you can do 0 as a test point. If 0 works in this equation, you would shade to the left. If it doesn't work, you would shade to the right. And it does not work in this case. 2 times 0 would be 0. Minus 1 is negative 1. Negative 1 times 4 is negative 4. And negative 4 is not greater than 12. Negative 4 is off to the left and 12 is way off to the right here. So that would be untrue. So 0 is not part of this solution set, which we know because y is greater than 2. We want to go to the right here. And it does not include 2, so we use the parentheses. That goes all the way to positive infinity. And then our interval notation is just that without the number line. We have our 2 endpoints, 2 and positive infinity. Put a comma in between to show the separation that we're including everything from here to here, from start to finish. And then we aren't including 2, so we use the parentheses, and we always use parentheses with the infinities. Okay, let's try 76 here. Same thing. We notice we've got an inequality. Our goal here is to get x by itself. I'm seeing it inside parentheses. I'm seeing it on both sides. Let's go all the way down through our checklist. First is the parentheses. We're going to distribute to get rid of. Why distribute? Because I've got subtraction or addition happening inside the parentheses that I'm trying to multiply by. And I can't combine any better because I've got a letter and a number. So I can't do any simplifying inside the parentheses. So I move on to distribution and multiplying it through on both pieces. So in this case, I'm multiplying a negative 2x through each piece here. So it's like 7 plus that. So it's the 7 stays here with the plus. Negative 2 times x is a negative 2x. Negative 2 times a negative 4 is going to be a positive 4. Less than 5 times 1 is 5. 5 times a negative 2x is a minus 10x. Okay. Now I'm looking to see if there's any like terms to combine. I took care of parentheses, like terms. On the left side, indeed, we've got 11, and I've got a negative 2x. So I'm just going to say negative 2x plus 11. I kept the negative sign with the 2x. I combined the 7 and 4 and got plus 11. So did a little movement around there, and that's just doing our chapter 1 abilities. Less than 5 minus 10x. Nothing changed. There were no like terms on the right side. From here, you want to get x to one side or the other. I'm going to go ahead and force the issue of making us practice what happens if we have a negative in front of a value. What happens if we have to divide or multiply both sides by a negative. So I'm going to head and move everything to the right so that it forces us to do that. And you don't have to do it that way. You could avoid the negatives by adding 10x to both sides. But I'm going to add 2x to both sides. How did I know to add? Because it's the opposite of what I see in front of the term that I want to move. I see a subtraction, I'm going to do the opposite by adding. And what I do to one side, I do to the other. 11 less than 5 minus 8x. Negative 10 plus 2 is a negative 8. From there, I ask what's happening to x. And in this case, 2 things are happening. It's getting multiplied by a negative 8, and then 5 is being added to it. Okay, if you're not convinced of that, think of this as 11 less than 5 plus a negative 8x. So it's getting multiplied by the negative 8, and then 5 is being added to it. Okay, don't think that 5 is being subtracted here. That negative belongs to this term. What's in front of the 5 is a plus. Okay, this is, and subtraction is the same as adding, the opposite. So really be straight with that. Okay, if you need to move those around so that it's negative 8x plus 5, so you can really see that the negative only belongs to the 8x. This is, the 5 is being added to it. Or if you were to do that in timeline form, you'd have x, and as you go left to right to tell us what's happening, you'd say I'd multiply it by negative 8, and then I would add 5. And then to undo that, you'd go in reverse order, so up the list, step 2 would be 1, and then your original step 1 would follow as step 2. Opposite operations, add would become subtract, multiply would become divide. Notice the sign stayed the same. I'm subtracting a positive 5. I'm dividing by a negative 8. The signs stay the same. It's just the operation that changes to its opposite. And as I go right to left on the timeline, I'd run into a plus 5 first, I'd make that minus 5. Then I'd run into the times negative 8, I'd make that divided by negative 8. The signs stay the same. For those of you that are having trouble, especially as you get 2.6 and you aren't sure what to do, go back take some of the problems from the earlier part of chapter 2 and talk yourself through every single step instead of doing it in your head. That's my guess. Usually when you get to this point and you aren't sure of yourself, it's because you did too much in your head early on. You didn't rehearse the steps out loud or on paper or whatever it is that works best for you. Sure, the answers, you got them, but you didn't prepare yourself for what's here. And what's here requires that you are confident with all the steps and there's no guesswork anymore. Okay, so you can pay attention to what's happening when you multiply or divide both sides by negative. That's the key to this section. So if you're struggling in this section, and it's, we haven't even got to the point where we've multiplied or divided both sides by negative on this particular problem. And if you're struggling already what to do, I'm concerned about signs, get the extra help that you need. Okay, make a note of where these problems start to get sticky for you and come talk to me or go to the Student Learning Center. Get the help that you need. Quit struggling and feeling like you're doing these with your eyes closed or you're blindfolded and swinging at a piñata that you can't see or that isn't there. Get yourself some clarity, some vision on how to do these, okay? You can do it. All right, sorry about the little sidetrack there. I just felt the need to encourage some people. Okay, so now follow what this prescription says. We start by subtracting 5 from both sides. I'm not multiplying or dividing. I use the word subtract. So there's no red flag here. There's nothing to eliminate. So there's nothing to flip, sorry. So 11 minus 5 is positive 6. The less than stays exactly the same. The 5's cancel each other. And I've got a plus negative 8 or 8x or just a negative 8x left. And that's exactly what I expected because that takes care of my first step. And now the only thing that's in the way is being multiplied by negative 8. We do the opposite. Divide both sides by negative 8. And right there, I'm dividing both sides by a negative. I hear myself say it. If you hear yourself say multiply or divide both sides by negative, right there you flip the sign. Okay, I divided both sides by negative. And what I'm left with is negative 3/4. 6 divided by negative 8 is negative 3/4, and I'm left with x. So negative 3/4 is greater than x, or you could write that as x is less than negative 3/4. And here's why. You've got your 0 as reference, here's negative 1, here's your negative 3/4. And you want to know when x is on the right side of the inequality, what does that mean? Does that mean I'm greater than negative 3/4? Do I read it like that? Or am I to the left? Which one is it? Well, remember, the alligator wants to eat the number, not the variable, okay? Or the alligator wants to eat what's bigger. So if you were to write it in terms of being able to read it left to right and put the x on the left, the inequality will still, in this case, still want to eat that negative 3/4, the alligator. So, or you can test it with 0. Does 0 make this statement true or not? If you plug in 0, is 0 less than negative 3/4? No, 0 is to the right of negative 3/4 on the line. 0 is not part of this solution set. We're including all the numbers less than negative 3/4. X is less than negative 4. Negative 3/4 is greater than all the possible answers for x. And we don't get to include it. It's an open statement. And then we can also write that in interval notation. Negative infinity, comma, negative 3/4. We do not include negative 3/4 because it's just a doesn't have the equal sign attached to it, and then also we never include infinity. It's always a parentheses for that. Okay, so on the next video we'll hit the try problems, and these are strategically picked, so don't pass by these. This is a good exercise. See you there.